Hi, everybody. I'm Bob Bowman, Editor-in-Chief of Supply Chain Brain. Welcome to this special presentation, Your Supply Chain Digital Twin, Why It Should Integrate with Design and Manufacturing, presented by Delmia, a brand of Dassault Systèmes. Quick reminder, there will be an audience question and answer session at the end of this presentation. Audience members are encouraged to submit their questions at any time during the presentation by clicking on that Q&A icon at the bottom of your screen. So, supply chain planners are under intense pressure to deliver speed, resilience, and efficiency, often while navigating incomplete data, frequent disruptions, and decisions made in silos. So today, we're going to explore how extending your digital twin to include design, engineering, and manufacturing can turn fragmented efforts into coordinated advantage. We'll discuss how better collaboration across teams leads to faster new product introductions, smarter responses to change, and improved business outcomes. With that, I want to introduce our speaker for today. Adrian Wood is Director of Strategy and Marketing with Delmia. Adrian has more than 25 years of experience in manufacturing, operations, and supply chain transformation. He helps high-tech and industrial companies drive digital transformation through simulation and virtual twin technology, with a focus on improving resilience, agility, and end-to-end decision-making. Welcome, Adrian. I want to pass it over to you for the presentation. Take it away.
Thanks very much, Bob. I appreciate it. Great to be speaking again to you out there in the supply chain world. So I'm going to start by posing a question to you guys in the audience, and it's a very simple question, and that is, what if? And I'm tempted to say this might be one of the most important questions in the world today. We know that supply chain disruptions are now the rule; they're not the exception. I think you guys in the audience are asking yourself this question almost on a daily basis. If you're in the tech industry, what if EVs, semiconductors, and battery components face increased tariffs? What if tariffs change in general for all industries? From a natural perspective, what if we have another earthquake in Asia like we did last year? What happens to semiconductor wafer output in Taiwan if that's offline for days at a time? If we're in food and beverage, what if we have a multi-state product recall? Or what if we have another avian flu outbreak? So these are all critical events that drive a ton of uncertainty for lots of different supply chain people in different industries. And the problem is they're really difficult what-if questions to answer. There's no simple answer to that. The complexity of the supply chain, the complexity of all the variables involved make it almost impossible to answer. So I'm going to pose the same question from a different point of view in a different context and see how you might be able to get the answer to some of your what-if questions. So my question is, what if you could model your entire supply chain network in detail and with accuracy? What if you could then run hundreds of potential scenarios and test all the different possible outcomes and options that you might experiment with before you take a single step in the real world? What if you could align all the stakeholders in your organization, not just within supply chain, but within engineering, manufacturing, and logistics, all in one connected system? So really, what if you could make better decisions and see what the impact would be before you make any changes in the real world? And so enter the virtual twin. The supply chain is no longer a linear function. It's a network of people, of partners, of raw material processes that all needs to be collaborative and orchestrated, particularly. And the virtual twin is a really powerful way to simulate, optimize, and synchronize all of your operations before you execute them in the real world. And it's the key to giving you the answer to these what-if questions, which are so difficult to solve. So you notice I'm using this term virtual twin quite consciously rather than digital twin. You might have heard of the term digital twin. It's very common. I know Bob and I were talking just before the webinar. I was like, I've heard of a digital twin, never heard of a virtual twin. Dassault Systèmes was a pioneer in digital twins. The first fully three-dimensional model of a production aircraft was developed by Dassault Systèmes in the 1980s. And we've continued to lead the way in the advancement of virtual worlds and virtual universes. And also now offering the new evolution of digital twins, which we call the virtual twin. The virtual twin is different from a digital twin. It's not just a replica. It's a decision support system. It's an ecosystem and experience that evolves with your operations. And it has a number of unique capabilities. It has end-to-end continuity. So it understands all the complexity of the supply chain that you manage, all the different variables, all the different partners in the ecosystem. It's model based. So when you create something or build something in the virtual twin, you can reuse it in context in other departments, other scenarios. It's collaborative and it's driven by real-time data. So it's a living, breathing model of what your operations are. It, of course, uses AI extensively for optimization, for prediction, for automation, lots of different ways that AI plays a role in the virtual twin. And it's also starting to become immersive in different ways, leveraging augmented reality and virtual reality. So you can take a virtual tour of your distribution center or your warehouse, or start to see and imagine your supply chain complex network in new visual ways. So it's not a replica, it's a decision support system. It's a different way of thinking. Digital twins were one of the key technology components of Industry 4.0. There was a term that was used a lot in the last decade, but they do have limitations. And I started my career in digital twins back in the late 1980s. If I had hair, you'd see that it is quite grey. But this is where, a lot of people put a lot of effort into technology to try and improve operations. But the trouble is, digital twins are sort of bound by the assets and data that we could feed into them. They were very often linked to ERP systems. ERP systems very transactional, and if you wanted to model something that was outside the scope of your physical operations, very difficult to do that. They were localized, so they represent sort of pieces of your process, but not a holistic view of it. Tend to be siloed, different people using different digital twin models in different places that didn't talk to each other. They were kind of transactional and directional, sort of like operational projects that were good to solve one problem, but were not adaptable to different ways. And the bottom line is that digital twins just don't keep pace with today's what if questions, the complexity of supply chains and networks in use today. And so to be effective in meeting the challenges of modern supply chains, there needed to be a paradigm shift of capabilities. And that's what we mean by the next generation of digital twins, or the virtual twin, which properly support the digital transformation and have key capabilities critical to realizing the ambitions and answering those what if questions in the next generation of supply chain planning. So first of all, they're only bound by your imagination. I mean, a lot of the answers and solutions to today's problems don't exist in today's systems and networks. And so virtual twins allow you to explore endless capabilities and things that are logical and don't exist in real life yet in ways that match the way we want to expand our innovation. They're obviously global. They take into consideration every part of the supply chain, global conditions and different sorts of data sets that feed into that. They're highly collaborative. They're designed to work with people in different departments and different stakeholders, so they work together in a real-time, closed loop process where it continuously gets better. So overall, the virtual twin represents a much more dynamic experience than digital twins. They allow companies to truly react and experiment with new and innovative business models in different ways in a highly collaborative manner. So the modern day virtual twin, the supply chain virtual twin, is it does a number of things. First of all, primarily it accurately models the full network that you have responsibility for, and those partners that are feeding into your supply chain network: suppliers, logistics, inventory, channels, raw material. All that's accurately modeled. It captures how the supply chain exists and also how it behaves over time. AI obviously are core elements, as we said, in optimization, automation, prediction. But it's about connecting the virtual and the real worlds together with real-time data so you can make actionable decisions. And it's about modeling all different levels of the supply chain. So in this animation here we have at the top half of the screen, you can see we're looking at a very strategic view of the supply chain. We're looking at a map on the globe in terms of where all our supply chain is, our partners, our suppliers, our distribution centers, and we're interacting with it to see what's the impact on our C-level KPIs, our margins, our profit, our fulfillment rates. That's the most strategic level, perhaps supporting an IBP or an S&OP executive process. But the details matter, right? So in supply chain, it could be the smallest detail that has the biggest impact. So in the bottom half, we're looking at scheduling down to a very detailed level, down to a production center, even perhaps one single manufacturing line within a production center. So on the top half, we're sort of looking at what's happening in the next 6 months, 12 months, 24 months. In the bottom half, we're looking at what's happening in the next 6 minutes, the next 12 hours, the next 24 days. It's all part of the continuum that makes up the complexity of your supply chain. It's important to be able to model all of that, as well as looking in the past, right? So we talk about AI being a part of the supply chain virtual twin. So we also have in the examples here, machine learning, so looking back at, well, why didn't that plan work? In fact, the last 3 plans that we did didn't work. They seemed perfect at the time. What went wrong? Well, it could have been external influences, could have been unplanned downtime or geopolitical events. And so machine learning is adept at sort of looking back and using the virtual twin to see what historically happened so we can make better decisions in the future to hopefully mitigate risk that we might even predict before it happens. So all part of the supply chain virtual twin. It's a really important piece of the puzzle. But it is just a piece of the puzzle. The supply chain virtual twin is a key part. But when I talk to supply chain leaders, when we meet them at the Gartner events, when we talk to our customers, we talk to analysts, very often what they'll say is, well, the problems that I have with supply chain are not in my supply chain organization. They actually are part of our product design, or they're part of manufacturing. If I could only sort that out, then the supply chain problems would be fixed. And this is a big challenge because very often the root causes are in these upstream and downstream processes that are critically linked to the supply chain planning process. So either in the product, where we do that product design and product engineering, or in the production systems, the manufacturing centers that we may have that manufacture the product. Now, if you think about that, then there are really multiple virtual twins that we need to consider. And if you think about it, there's a product virtual twin, there's a supply chain virtual twin, and then there's a production systems virtual twin. And actually, the bottom two virtual twins are far more mature in terms of adoption, in terms of operational use, in terms of capability. Your counterparts in your organization, VP of engineering, VP of operations, VP of manufacturing, are often have been working quite diligently to connect these virtual twins and connect the digital thread between the bottom pair for decades now, with a ton of success. I mean, there really is a lot of proven success and value in the virtual twins that we see in the bottom and the connection between them. And these virtual twins have been adding value in their own domains, and the connection between them provides even more value. But these three are really interconnected. And the same digital thread that connects the product virtual twin and the production systems virtual twin now needs to start expanding to the supply chain virtual twin, because they really do have dependencies on each other that can hinder or contribute to planning success. So we believe that efficient innovation requires collaboration between supply chain, its related divisions. And we believe that to be really effective in adapting and being agile, resilient to change, to be able to answer those what-if questions, then you really have to plan holistically and connect and orchestrate the decisions that you make in the supply chain virtual twin, along with engineering and manufacturing. We've had this hypothesis and this belief actually for several years now. We wanted to see if the concept was prevalent across different types of supply chains, different companies, different size of companies, different industries. And so we asked an independent analyst firm to do a survey for us. This firm was Tech Clarity. You may have heard of them before. And Tech Clarity designed a survey to try and identify the factors that drive supply chain effectiveness and operational success. In order to do that, first of all, they had to determine, which companies had more operational success. So part of the survey, which they sent to about 230 different supply chain companies, all different sizes, all different industries, was to determine, who are the top performers. And the way they did that was to find out how those companies were performing in terms of key C-level metrics. Examples: new product, service, and revenue. Time to market goals for new products or when they're introducing new products, revenue growth over the last 2 years, profit margin expansion, all these things which the C-level suite would look at and say, yeah, we're doing really well. And they found out that based upon that, there were 23% of the companies that fell into this sort of top performer category. And then, of course, the rest of the survey was about, well, what are the factors that are going on inside these organizations that make them top performers? What are they doing right that really sets them apart from the pack? Now, this was not a fait accompli. I mean, obviously, we did contract the survey with clarity, but the survey covered all sorts of potential factors, planning cadence times, data accessibility and availability, maturity of planning process, technology in place, communication, collaboration. There were a number of different survey attributes that looked at all the different things. And by the way, at the end of the webinar, we will give you a link where you can go and download this ebook that has a survey results in it, because there's a ton of really interesting stuff about what makes top performers top performers. But the most key thing that we were looking for was what's the number one top performer attribute or factor that makes them so successful. And we were really pleased to see that it did prove out our hypothesis. For 73% of the top performers, the number one factor in terms of what made them different, what made them better than their peers, what drove them to better results in terms of those key KPIs, was good collaboration with production, engineering, and product development. So they worked closer with their counterparts in the connected ecosystem, and that's what was the primary driving factor in why they were more successful than their peers. So again, take a look at the ebook at the end. We'll have a link for you to go download that. So based upon that survey, we continue to believe that this orchestration of the three virtual twins, product, production systems, and supply chain, are really critical to addressing industrial operations and answering today's what-if questions that are so complex in a definitive manner. So what's shared? What are these companies collaborating on? What needs to be shared to have the best effect? So let's start with between the product virtual twin and the supply chain virtual twin. So one thing that's shared from design to supply chain can be shared is variations of design specs. So in a discrete world, bill of materials, in process and food and beverage, for example, ingredients and recipes. Because if we can do that when we're designing products, the supply chain has a better chance of optimizing the supply chain configuration and sourcing as we're designing the products. And in return, of course, as we see challenges or new opportunities in sourcing, if we can feed that back to our design process while the product's being designed, we can make products that are already optimized for the best possible use in supply chain. We do this because we can reduce the risk of design not meeting supply chain capabilities, and we can make sure that we are building products sustainably and optimized for increased market share and fulfillment. Between the production systems virtual twin and the supply chain virtual twin, obviously one of the things we want to know about with visibility and immediacy is any tactical disruptions. So labor shortages, material shortages, outages, unplanned downtime that brings a key plant down or even a key production line down, that needs to feed back into the supply chain instantly so that we can then perhaps make different decisions about, can we outsource some of the contracts manufacturing to contractors? Can we find different product that perhaps has less quality issues? And similarly, as we make strategic changes in the supply chain, we can then bounce that against the production systems virtual twin to see, if we try different component parts, or we have different quality materials or different materials in the components, are we able to manufacture that effectively, or what impact might it have? And again, we do that because we can reduce the variability or the difference between what we plan and what we execute to make sure that we're maximizing our service levels, throughputs, and our margins. As we said, the bottom loop has been in place for a long time. I mean, really, supply chain is a bit behind the curve in terms of the collaboration effort. But now we can extend the digital thread up to the supply chain and start getting the same benefits that we've seen in the bottom part between manufacturing and engineering. And working together, these virtual twins provide an orchestrated way to allow companies to experiment and plan really rapidly while understanding all the constraints and ripple effects of decisions. So I wanted to show you an example to sort of bring it to life a little bit. Pick one of the workflows. There are dozens between these sort of orchestrated connections, but I'm going to pick one between the product virtual twin, so the design phase, and the supply chain virtual twin, just to show example of how it works and how rapidly you can share information. So here we're stepping into the designer's shoes, the design engineer, right, who's working in an automotive company. We're making some changes to one of the products in our lineup of vehicles, and we're changing some paint color. Well, that might be something we need to think about in terms of manufacturing capability. If it's a different type of paint or sprayer, that's great. The products are virtual twin, the production system virtual twin can figure that out. But we're also going to make some changes to the interior trim, perhaps. We're going to make some changes to the wheels and the wheel rims, and some of these changes will include new component parts, perhaps, that we haven't sourced before. So as soon as the designer makes that change, now we can step into the role of the sourcing specialist. The sourcing specialist can start to say, oh, I see I've been notified there's a change in a potential design. Let me go see what they need. And there's a new component part we haven't sourced before. Let me go see how I can source that. And of course, there'll be different suppliers in different parts of the world that have different lead times, different costs for the part, different ESG requirements or quality issues, perhaps. We can start to evaluate, well, what's the best supplier, based upon all the information that I have that might be able to get us this new part that design is so interested in feeding into the product. But based upon that, then we can immediately say, well, I'm going to select this one because it seems to be the best. But now we can immediately step into the supply planner's shoes. And we can start to see, okay, well, here's a change from design, and sourcing says this part might work. Let me see what that means in terms of inventory levels and stocking levels. And, is there enough supply to support the demand plan that we have? And then we can go immediately and step into the shoes of the master production schedule and say, well, I see there's a change in design. We've got this part, we've got enough supply, we've got this much supply. What does that mean to our production? Can we make enough of this part based upon the demand plan? Do we have to sacrifice other products in our existing portfolio? Do we meet demand? Do we have to outsource contract manufacturing? And I'm presenting this as quite a linear flow from one step to the next, but you could start anywhere in this process, and any change that any one of these stakeholders makes is instantly propagated to everyone else in the process. So it doesn't have to be a directional flow from left to right. It could be the supply chain seeing a change in sourcing and saying, hey, we've got a problem here. Can you change the design of the product? Can you adapt the product in any way to sort of take advantage of, this supplier's gone out of business? And so this sort of many-to-many connection of everyone working from a same vision of the truth, and everyone seeing exactly what needs to happen at the same time, is really unprecedented in planning. And I think that many of you on the webinar here will probably say, well, we kind of do that in our company. We always look to see what design changes are being made. Yeah, you might do it. I think many of you might not, actually. I think a lot of times this does happen in silos. But I'll guarantee that if it is happening in your organization, it's not happening at this speed. And the difference between making these sorts of decisions in minutes or hours versus weeks or months, or perhaps not being able to make the decision at all, is just one example of how connecting the digital thread between these virtual twins can lead to unprecedented levels of agility and efficiency in planning, and is making a significant change to the way companies can again answer these really complex challenges. So that's just one example of one workflow. There are dozens of potential workflows that show how these the orchestration between these virtual twins work together. And there's lots of examples. As I said, in the bottom half of this graph between the product and the production systems virtual twin, there are hundreds of companies. Pretty much every automotive company, every aircraft manufacturer already connecting the virtual twins and the digital thread between the two. But now you're starting to see companies take the same approach and innovation to connect the product and the supply chain virtual twin, like Faurecia, reducing the risk in design of new products so they can optimize market share and fulfillment. Companies like Hexcel, who are doing digital transformation of their supply chain and their manufacturing process at the same time, so they can start to enable rapid demand analysis, supply chain optimization, and then balance that against the detailed process plan and execution they have in their manufacturing operations as well. So lots and lots of opportunities in all areas, but now seeing new innovation in the supply chain area. So very, very quick summary, just to recap some of that. So if we go back to our starting point, what if? Can we answer those what if questions? Well, it's not just about being faster or cheaper. It's about being smarter in the way you do decisions. It's about being more collaborative. It's about orchestrating decisions. Virtual twins make that possible. Remember, 73% of top performers say that they are succeeding. They're leading their peers in their industries because they are integrating supply chain manufacturing and engineering. And that integration gives real results: faster new product introduction, lower costs, improved accuracy, better resiliency to the unprecedented changes that we've seen over the last 10 years. Virtual twins of the production system and supply chain are the key technology that help enable these agile end-to-end decisions, this orchestration between the two. And of course, AI playing a big part of that as well. So it's a fundamental mind shift in terms of the change. and something that we believed for a long time and now have seen it proved out and starting to see. And we hope some of you will also start to take that next step along that journey. And Bob, I think I'll turn it back to you. I think we've got some questions to cover related to this.
Yeah, thank you so much, Adrian. What a fascinating presentation, really delving into the importance of collaboration between the supply chain and all aspects of production. Thank you very much for that. I do want to remind you all that there will be an audience question and answer session at the end of this presentation. But for now, an audience member should be encouraged to submit their questions all along at any time during our discussion by clicking on the Q&A icon at the bottom of your screen. But right now, I have the privilege of asking Adrian some questions to kind of take a deeper dive into what he's talked about and expand on it a little bit. So, Adrian, we talk all the time about the dangers of silos, of corporate silos. What are the signs that a company might actually be ready to move beyond siloed planning?
Well, I think first of all, most importantly, if you're asking those what if questions and you're not able to get an answer, that's the first sign, right? So it means that fundamentally there's some complexity or challenge in your organization that is preventing you from answering those questions. But also, even if there are simpler questions, if teams you find are frustrated with rework, surprises, they're firefighting in different modes, then it's probably the same sort of thing. This is something which, again, digital twins have been around for a long time, not really answering today's questions, and so people are looking for different ways. I think also, as I said, the people in the audience here, probably all from the supply chain part of the business. Your counterparts have been investing in virtual twins for the products and production systems, but you're not maximizing the investment that you've made in those systems. So if you're using supply chain technology, but you're not feeling like you're getting the ROI out of it, you're still not able to answer those ROI questions, you're under leveraging the capability, not connecting those systems together, which is a key part of multiplying the value that you get in each of those departments by working together.
Boy, it's so hard to break down those silo walls, but this is a great way, a great excuse to begin doing it. Thank you. What is the link, Adrian, if any, between integration that we've been talking about and the ability of a business to better respond to volatility? Do you see an exact link there? How does that work?
Yeah, there's two things. It's about faster scenario planning, but a lot of technology today will give you, rapid optimization and rapid answers to, what if questions within the supply chain organization. So it's not just about faster scenario planning. It's about faster scenario planning based upon the real constraints across the entire product lifecycle, across the entire organization, across design, engineering, and manufacturing as well. And the integration allows people or companies to find really creative ways to solve problems collaboratively. The answer normally can't be found just within one silo, one organization, one department. The supply chain challenge might actually be best served by finding an answer in the design of the product or by manufacturing as part of the process. So like I said, we're all about providing virtual universes to organizations to unleash their experimentation and experimentation. And that's part of it, is finding these creative ways. It's connecting the product lifecycle basically to decisions and real-time operations, so you can continuously find different ways to enable different ways to plan based upon all of the elements of the product, not just the supply chain elements.
We don't want to make it seem like you can just sort of snap your fingers and suddenly you're collaborating and bringing down the walls and all three aspects are all talking to each other and working well together. There are indeed a number of barriers that exist. So what, Adrian, do you consider to be the biggest barriers that prevent this seamless integration between supply chain, engineering, and manufacturing?
I think that the two are people and technology. We always talk about people, process, and technologies, the three legs of the stool. Process, yes, but first of all, it's technology. The legacy systems that don't talk to each other effectively is one of the biggest challenge. But people also, if you think about it, and this is a challenge, right? Again, we've got some great audience on the phone from supply chain. I very rarely find myself talking to supply chain people and manufacturing and engineering people at the same time, because they are functional silos. They don't tend to go to the same conferences. They don't tend to read the same papers. They have separate KPIs and separate incentives that are all driving their own behavior. And so I think, as well as the systems that don't talk to each other, it's the people that don't necessarily talk to each other, because they're not aligned to do that. But obviously, from a technology point of view, if you're dealing with manual, legacy spreadsheet sort of work, or lack of a shared platform or data model, that's a challenge. But I think people have a big role to play in this as well.
Yeah. But I would imagine that product and production systems share the same issues. They've got the same people and process and technology problems. So why is it that you identified supply chain as lagging behind the curve? Why specifically supply chain? What has been the problem there?
I think perhaps there's been a legacy and a history of working on the model of the product first. I mean, that was the first virtual twin that was developed. The 3D wireframe of the plane or the part, or whatever you can imagine, that's been happening for a long, long time,
Sure.
30 years or more. And then we started to think about models of the factory and facility. Because the supply chain is more of an abstract concept, I think people didn't think about it so in such a way as like a model. But it is a living, breathing model. It's the same way. It's just made up of nodes and connections and logistics capacities and different, rather than sort of components and pieces and parts. But so I think it's been a slower adoption, but actually all the same advantages that you get from virtual twins of products and manufacturing centers can be applied to the supply chain as well.
And all those extended tiers of supplier partners that have to be brought into the picture as well. Supply chains are definitely must face that. So much of it happens outside the walls of the company itself. So
Yeah.
I can see how it might be a problem. Why is it so difficult, though, to achieve visibility specifically into manufacturing constraints and product changes?
Disconnected systems. So
Yeah,
the design people will have their CAD systems, their PLM systems. Manufacturing will have MES and ERP and APS, perhaps a little bit, and supply chain has their own. These systems don't necessarily, talk the same language. And again, that's a fault of digital twins. They're not model based, right? So a part of the model that you build, let's say a manufacturing model of a manufacturing facility, is something that you can actually reuse and represent in the supply chain model. You can use it in the design model to see how you might virtually build a product as well. But I think the challenge is there's no single source of truth. Companies are using different platforms for different systems, and it doesn't transfer easily from one to the next, but it actually can. I think the other challenge is that I think people just sort of, supply chain people sort of think, well, manufacturing is sort of a downstream problem. We've done the
Mhm.
best, manufacturers to figure it out. Same as designers, an upstream problem. Like designers, they love to change things. We've got to do our best. It's not integral to the planning process to involve these different people in that process, let alone the systems beneath them.
Well, it should be. I guess it's becoming more and more the case. I asked you before to describe the link between integration and volatility.
Yeah.
What about the link between integration and innovation? How has that come to the fore when you're by connecting these areas?
So if you can have different people sort of put themselves in the shoes of their counterparts, if they can start to see how a change has an impact on if a design change has an impact on the supply chain, how a sourcing change that might have an impact on a product design or a manufacturing capability. That integration suddenly allows people to look at the problem from three different points of view and all work on the same problem at the same time and see the impact. Typically, this is very much even if your companies are doing it very rapidly, it's still sort of passing information from one silo to the next and seeing what the impact is. You can't see the ripple effect like that. So the integration allows you to make a change, like dropping a stone in a pond and seeing the ripples sort of propagate outwards and say, I didn't realize that was going to happen based upon that. So that integration is really important to unlocking the sort of innovation and the view of what changes really mean in supply chain across the organization.
And that way you're not so much playing catch up with the crises and the unexpected things that happen. You're
Yeah,
on top of it to the point where you can now look forward and you can now focus on innovation instead of firefighting backwards.
that's right.
A
Yeah,
good point.
exactly. Yeah.
Okay, so this is a massive effort involving a lot of people, but shouldn't there not be somebody kind of at the helm leading the whole integration effort? And if so, who?
You're right, it is, because as I said, I very rarely find myself speaking at conferences or on webinars where I have a cross-functional audience of manufacturing, supply chain, and operation.
Sure.
Sometimes I do, but so ideally you would have a cross-functional transformation team involved in this, clearly, because you need to have all parties part of it. And I think because of that, you do need executive sponsorship from the C-suite. I mean, we say that a lot. like you have to have executive sponsorship. I think this is really a key part of this transformation because it's the CEO, COO that has this sort of wide angle view across all these different operations. So that's really, really key. You need planning leaders with strong influence across functions. So, again, my advice for people on the call here and sitting in supply chain, maybe go find your counterparts, go find the champions in engineering and manufacturing, because I promise you that they're dealing with the same issue. Like they're sitting there saying, "Oh, if only supply chain would, align with the way we do things." I mean, they're all struggling with the same problem. Go find those manufacturing champions and start building a case for it, and then go find executive sponsorship to sort of embark upon a digital transformation.
You say CEO, COO. So what about a chief supply chain officer? Is that already too much of a silo to start with?
So it depends upon their scope. I know chief supply chain officer can have a perhaps broader scope than a VP of supply chain. So as long as that person has purview or sort of scope over at least part of the manufacturing or engineering process, that's fine. I mean, it's not about the title. It's about the role and scope of responsibility. And I think in larger companies, it might be more segmented. In smaller companies, you might find, people like that have broader influence.
Okay, so again, we're urging everybody, it's the kind of a ready, set, go. Start collaborating right now. Do all this, but of course, it's a massive effort.
Yeah.
Certain things have to happen first. What would be one piece of advice, Adrian, that you could share with us for actually just getting started?
Yeah. So, and I think I saw a question come in about, how to implement and how to get it done. So I think one way to do that is, it sounds quite complex. It can be quite complex to put all three virtual twins in place and orchestrate them. You don't have to do the extreme level of detail. So find a use case that sort of starts perhaps at an aggregate level to simulate some cross-functional trade-offs. Look for a situation that doesn't require, every part of the supply chain to be modeled or every part of the design process to be integrated. The other thing to do is to try virtual twin as a service or digital twin as a service, I guess is a possibility, but I'm not sure it really captures that. But I know that for companies that are not ready to implement, a big ton of software or platform, or they say we just don't have the capital budget this year or whatever. Virtual twin as a service, which is an outcome-based engagement, is something that we've found very successful with customers that want to sort of dip a toe in the water and start to model some of their operations, but have a vendor do it for them so they can sort of get started, prove out some points, and then build a business case to go implement. And even after that, we'd recommend companies pilot, a small-scale integration use case like new product introduction against a demand spike, that sort of integration of use case between the design and the supply chain, and sort of start small and then expand from there. Again, because virtual twins are model based, nothing's thrown away, right? You always reuse what you build. Obviously, you have to treat it as a journey and build maturity over time. But there are lots of ways to start small and build some proof points.
Virtual twin as a service. I'm waiting for the acronym VTAS or something like
VTAS.
that.
VTAS.
We do love our acronyms in this business, don't we?
We
Okay,
do.
great. Well, thank you so much for those answers. I really appreciate it, Adrian. At this point, I want to bring the audience in because we do have some audience questions already queued up here.
Yeah.
And I'd like to hit you with them as they come in here.
Different.
So let's start with this one, and it's simply saying, how long does it take? I mean, we talked about, the first steps and things like that, but how long does it take to implement a virtual twin?
Yeah.
Here again, is saying, can it be done in pieces? You talked a little bit about that, or does it need to be all in before we start to even see value?
You can do it in pieces, right? I mean, but it's kind of like how long is a piece of string, but yes, absolutely, you can do it in pieces. You can start with specific use cases and you can build out models of those particular situations and experiment with them, see what works first. You do not have to do, you don't have to model the entirety of your supply chain in all its operational details down to the what's happening at a minute by minute level in order to get value, but that will come. But I think, again, the difference between a digital twin and what we see as the virtual twin is because it's model based, whatever you build is reused. And so, it lives and breathes, it's connected to what's happening in real life. And so, yes, there are plenty of ways to start small and find those use cases that prove out the concept, and then you can expand upon them without having to lose anything in the meantime.
You mentioned earlier in your presentation about the necessity of dealing with multiple software systems.
Yeah.
So I have a feeling I'm going to know what the answer is to this question coming in from the audience, but why don't we try it?
Yeah.
Can you integrate multiple software programs and platforms, or do we need to buy a single solution?
Well, what are you expecting me to say, Rob?
Well, there's just one massive answer for everything, is what I expect to hear you say.
Um,
So,
so obviously, we think of the ultimate solution as a single collaborative platform, but we
right.
also know that we have to live in the real world. All of our customers are using lots and lots of different software technology, not just between the three virtual twins, but within the virtual twins as well. We are more than happy to coexist and integrate where it makes sense. You will get value from that, even if we're integrating across a diverse system or a diverse set of different systems. You'll get more value if it's on a single platform. But yeah, there are ways to integrate. And of course, that's part and parcel of what we do is, no one says, I'm going to throw it all out and I just want one platform. They get there over time eventually. But yeah, we are quite happy to work in quite diverse environments.
Okay. Questioner Notes points out that we made it through this explanation of the virtual twin without saying a whole lot about AI. How will it work with the collaboration that's so important for excellence in supply chains?
Yeah, well, I mean, we had a whole other webinar just previous to this one about AI and supply chain. I encourage the listener to go back and find that one. AI is a key part of it because optimization is a key part of getting answers to some of those decisions. So even though you collaborate with people, those people are still using AI. And now we're seeing really interesting use cases where you're using AI to generative AI, next generation AI, to try and come up with answers that span supply chain and design together, which I find really, really fascinating. But there are lots and lots of AI instances across the traditional use cases of, optimizing a demand and supply plan, uh, machine learning for forecast accuracy improvement, optimization of design, all the rest of it. So it's embedded throughout. I didn't focus as much on AI because we had that other webinar last time, but it is a key part of it as well.
Okay. Here's a good question. So, what are the benefits and challenges that virtual twins provide to supply chain risk management?
I think that's the best part. 'Cause everything about today's disruption is about risk. I mean, we are facing risk every day in terms of, tariff prices going up or supply being cut off or whatever. So I think what people want to do is they want to say, well, what if? And that goes back to the very first slide. What if that happens? What's the risk? And the virtual twin allows you to, work in this universe of endless possibilities and run unlimited scenarios to determine what is the risk and what's the parameters, what can we do, and what are the boundaries of what's the worst case, the best case, what's most likely. There's a whole host of ways that you can use it to. You can't eliminate the risk, but you can certainly mitigate it as much as possible.
Well, the term "what if" is automatically a risk management question, isn't it? I
Absolutely.
mean, by its very definition. So here's another aspect that we didn't talk much about, but it's essential to today's supply chains, and that is sustainability. How does
Yeah.
all this impact sustainability goals?
Well, I mean, one thing that you can do as part of the virtual twin is obviously the product virtual twin has been used quite extensively to design more sustainable products. And I think I forget the statistics, something like 50 to 60% of the sustainability aspect of a product is influenced in the design phase. But you've got a lot of downstream operations and movement of product throughout the supply chain, CO2 emissions, and so on. But I think it's about what you can do is not only you can design for sustainability, but you can start to optimize the supply chain network for sustainability as you design together. It's collaborative design of a product in the same phase to say this is the first part of the optimization for sustainability, but we can see how is it best optimized in the supply chain. You can simulate packaging strategies, logistics strategies, and also you can start to simulate potential circular economy strategies. So design for disassembly. Here's a great example of the product and the supply chain virtual twin working with the production systems. If we wanted to, how could we best disassemble this product? And if we disassemble it, what's the best product design? And then if we're going to do that, what's the best supply chain network design to include the reverse logistics loop so we can get the product back to those disassembly points? So it's a great example of how you can use these three virtual twins together to sort of come up with the optimum sustainability strategies.
Every single aspect we talked about that in the forward supply chain similarly applies in the reverse supply chain and the so-called circular supply chain, which is the ultimate goal here in sustainability these days. What about measurable results, though? What are the metrics? How you got to show ROI, you got to show results to the C-suite. Where do you get those measurable results? that come from deeper integration?
Yeah, I mean there are a ton of different KPI buckets that are impacted by the virtual twins. It really depends upon where you start and what you're looking at. But I think one of the biggest metrics is the ability to react to change and to survive. The justification for supply chain technology, planning technology has become, thankfully a lot easier in the last few years because everyone knows that the challenges are sort of outpacing today's technology. But certainly companies are looking for a reduction in lead times. And in fact, back to the Tech Clarity survey that was done, they measured top performers by, how long it takes to get products to market, new products or new services or changes to products, revenue increase, margin increase, and different. But you'll find also, a whole host of different levers internally, like reduction in inventory levels and WIP levels. But I think faster time to market, better new product introduction, which is a part of everyone's supply chain and company imperative today, is key. As well as fulfilling those orders. I mean, getting those products out, getting to the customers on time.
That last question was trying to elicit from you answers about these measurable results, the hard numbers that can show what you're doing. But this next question takes a different angle, something that's not quite so hard, but equally important, and that is the word trust. Here again, we talk about bringing down walls of silos. Maybe this is a key aspect. The question is, how can organizations build trust across functions?
Yeah, and it's challenging because, as I mentioned, the functional leaders of the virtual twins of production systems, supply chain often have different KPIs, but I guarantee that they all have some shared KPIs. So I think the first thing, as you're trying to build trust across its organizations, is align on those shared KPIs, on time in full, cost to serve, time to market, whatever it is. There'll be metrics that everyone is tied to. That's one way to try and build trust, is make sure everyone's sort of pointed in the same direction in terms of the results they expect. The collaborative platforms actually help build transparency and feedback. So it makes a tremendous difference if you're working on the same set of data and you see the impact that your decisions have on someone else versus throwing it over the wall and then finding out 2 months later that that decision you made was the worst thing in the world for that process downstream. So training people to speak each other's language, making sure they have collaborative transparency and visibility to the impact of decisions is a key part of building some of that trust.
Again, to this question of delivering the promise of this effort in the form of ROI and demonstrated benefits, the questioner is asking about some quick wins that companies can pursue to help build momentum of the larger initiative. There are literally, if you start thinking about this orchestration, it literally opens up sort of dozens of new scenarios that perhaps you haven't thought of before or that weren't available. And there's lots of quick wins that we've seen. So again, new product introduction, we come back to that a number of times, linking new product introduction planning with distribution capacity analysis. Having a use case where you say, well, if we introduce this product at scale, can we actually get it through our network to our customers, and can we meet demand based upon that? That's a great example of the product and the supply chain virtual twin. Aligning demand planning with engineering change schedules. So, engineering, the common phrase is, designers and engineers, they love to change things. Well, yeah, but if you can start to look at demand planning, demand sensing, actually, or voice of the consumer, and start to feed that back to engineering change schedules, so you align at least significant market changes to the process of making engineering changes. That's a great way. Experiment with tariff rate increases and zero in on potential design and sourcing challenges. And so that's one thing I think a lot of people are doing. They find it very difficult is, if this raw material in my network, which is at my tier 3 supplier, goes up to 200% in price, what does that do? And could I design my product in a different way that mitigates that risk? That's a great example of the supply chain and the design process. I'm not sure where you want to go with this question. It says, what kind of data must be connected to make integration work? Well, you're going to say all data? I mean, that's a massive, massive challenge. Can we prioritize? Can we talk more specifically about the types of data that it's most important to connect?
Yeah. Well, I think, again, back to the other question that someone asked is, do we have to go all in, or can we do it in pieces? What data that can be connected can be just what's needed for that use case. And that one slide had this sort of view of sort of some of the things that are shared, but from an engineering perspective, what kind of data from engineering, for example, bill of materials, part attributes, product configurations, manufacturing, routings, resource capacities, maintenance schedules would be really good for supply chain to understand, when and where there might be challenges in capacity for planning. Supply chain should be sharing demand forecasts with, as I said in the use case before, with engineering change schedules, supplier lead times, inventory status. And I think there'll be a lot of shared, data as well, planning parameters, quality feedback, those sort of top level metrics, ESG as well. So no, but you don't have to share everything, right? But the use case will determine what needs to be shared.
That's good to know. Well, Adrian, thank you so much. Fantastic presentation. Audience, thank you as well for your great questions. Unfortunately, we are just about out of time. We have time for one final question, and here it is, Adrian. What is the danger in optimizing one department without the others? And how should a company start to align them?
Yeah, so I've used this analogy quite a lot. You remember these, right, Bob? You remember the Rubik's?
Rubik's Cube.
Yeah,
Yeah,
I found one on my shelf just over here. And you remember how complicated it was and frustrating it was to
I
try
never
and
managed to
get.
do it.
Well, I never did either.
Yeah.
I took it apart like everyone else and put it back together. To try and get one side of the cube the same color was challenging enough. I think planning your supply chain without manufacturing and engineering is kind of like having three people solve different sides of the Rubik's Cube at the same time. I mean, it's impossible. You're never going to do it. Every turn that you make messes up the other person's side. And that's a critical challenge that happens in supply chain. So I think what companies need to do is that they need to change their mindset. They need to start to look at how virtual twins can bring all the stakeholders in that process, all the people trying to solve those different sides into one collaborative environment and connect the digital threads that need to exist between them across the entire product lifecycle. As I said, it's been proven for years in engineering and manufacturing that they've worked, that connection has worked, the virtual twins work. I think now it's time for the supply chain group to get the same results and have their share of the results.
For sure. Again, Adrian, thank you so much. Excellent presentation. Audience, thank you so much again for your participation. We have a couple of assets for you here. One is the survey ebook, Transformation for Supply Chain Resilience. And the second is what Adrian already alluded to in answer to the question about AI, episode 1 of this series. The title was AI Making Your Head Hurt? Good. It means you're future proofing. There's a couple of QR codes for you right there that you can access the links to those assets. But if you're unable to take a shot of them in time, they're already gone. Don't worry about it. They will be sent to all attendees of this webinar upon its conclusion. One more thing to check out there at the bottom. There is Adrian's contact information. I'm sure he would love to hear from you and continue this conversation going forward. But for now, it's over. We're out of time. Thank you so much, Adrian. Really great. Great to have you here. Thanks again, audience. Everybody, have a great day.
Thanks very much.